organizations to implement their own cloud-native security playbook. This session is going to be designed specifically for Blue Cross Blue Shield security teams that are navigating hybrid deployments and migrations, as well as multi-cloud environments. As we've seen, Blue Cross Blue Shield organizations modernize member services and migrate, sensitive PHI data to the cloud. The need for consistent security policies, managing cloud costs, and unified visibility has been a key item that has come up. And today, Tom Davis and myself are going to explore how Aviatrix Cloud Native Security Fabric has delivered a proven blueprint for zero trust enforcement. One thing before I truly introduce myself and our other speaker is I wanted to add that if you have any questions, please submit them down below at the Q&A panel, and then we're going to attempt to answer those questions live throughout the end and towards the end. So go ahead and we'll move on to the next slide. I want to introduce myself. My name is Sam. I'm a product marketing manager here at Aviatrix and excited to be talking about the Cloud Native Security Fabric. Passing it over to Tom.
Hey, good morning, everyone. Tom Davis, I lead the industry solutions practice here at Aviatrix, and very excited to get into this webinar. We've been planning this event for some time, and incredibly excited to lead this with Sam. So let's go ahead and get started here. So the first thing I want to spend some time on is to talk about kind of the evolution of healthcare, specifically relative to hybrid cloud architecture. And what I want to do before I get into kind of where we are today, I want to kind of take a step back and look at kind of where we've been or where the healthcare industry has been. I'll say somewhere around 2015, 2016, and really earlier, within the healthcare industry, the users were sitting at a branch location or an office location, and they were behind a firewall. Anytime they wanted to go access the internet, they were going through a really big firewall and making sure policy was there, et cetera, and being enforced. As well as the data and the workloads were sitting in, most of the time, a data center, in some cases a colo like an Equinix, as an example. But again, you had a firewall that protected those workloads and the data from the public internet. Everything was centralized, it was contained, and for the most part, it was static. And so over the course of the last, I'll say 8, 9, 10 years, what we've seen is data start to be distributed across public cloud providers like AWS or Azure or Google Cloud or Oracle. And you start to have distributed data and distributed workloads across these different cloud environments, as well as a private cloud or your traditional on-prem data center still housed, your SAP, your mainframe application, your legacy applications, or even in some cases your crown jewel applications. And then users, primarily I would say during the kind of the COVID time period from 2021, et cetera, that kind of amplified everything. But now users are everywhere, right? There's a lot of remote workers distributed sitting in Starbucks or in coffee shops or in WeWorks and their home office. And so users are everywhere, workloads are everywhere, application data is everywhere. And then, as healthcare entered into kind of the hybrid cloud architecture, we started to see Terraform start to become kind of the de facto standard for infrastructure as code. And so you start to see GitHub repos in terms of your data. Software applications started to SaaSify their applications as well. So what we see today is that applications, workload, and users are distributed. And really there's no clear perimeter between the users, the workload, the data, and the public internet, which was ultimately always deemed very, very bad and kind of the wild, wild west. And the architecture is also very dynamic, right? Mergers and acquisitions are happening. You're spinning up new regions. You're spinning up new accounts. You're moving and building out a DRHA design where you're moving applications to different regions, et cetera. And ultimately, this has created a very complex technical ecosystem. And for Blue Cross Blue Shield entities specifically, I think what I've seen in all of my discussions and through our customers and through talking with partners and prospects, I see that Blue Cross Blue Shield entities are everywhere on this spectrum, right? In some cases, they are very still on the left, right, where all the applications and data and workload and everything are holding on really, really tight to say we're going to keep everything, out of the public cloud and in the arms around our big firewalls. Or there's more, I'll say, advanced Blue Cross Blue Shield entities where they are using multiple public clouds. They are using everything I talked about earlier and having some challenges around, kind of securing that, knowing this kind of very technical, complex technical ecosystem. So not only do you have this complex technical ecosystem, you also have regulatory pressures and compliance pressures from HIPAA and high trust CSF and GDPR, depending on and high tech, depending on where you are geographically. And I'm sure you guys have all seen this, but the proposed HIPAA mandate updates that will likely get through early 2026 are driving towards a requirement around application segmentation and ability to visualize EPHI or personal health information data flows, making sure that all traffic is encrypted at rest and in transit, providing central governance and visibility, as well as improved data interoperability. So these are some of the things that are also pressuring the healthcare industry while they're facing that very complex ecosystem.
Hey, Tom, real quick, before you move on.
Oh, yeah.
Sure.
I
had a question come in that I wanted to flag. You mentioned the compliance mandates, HIPAA 2.0 and the 2025 compliance mandates. And these are a lot of requirements that are coming through, especially for organizations that are still trying to migrate over. How should organizations handle this? There's a lot of, PHI encryption, network mapping, improved IR. These are a lot to handle. How should organizations think about this when trying to prioritize and meet the compliance mandates?
Yeah, it's a good question, and it's a question that I'm having almost daily right now. Not specifically with Blue Cross Blue Shield entities, but with healthcare organizations in general. What I'm starting to see very common is Cloud 2.0 or next gen hybrid architecture initiatives being created, and really what that's made up of is the evolution I just spoke about, right? In terms of where we were and where we are today was built through evolution and built to reactions, right? Whether the business says, hey, we're starting off in AWS, I want you guys to go check out AWS, and then 2 years later they say, hey, we just signed this EA with Microsoft, and now we're going to start moving some of our maybe our EHR system up into Microsoft, and then 2 years later they're like, okay, we just bought this company and we're gonna merge our cloud architecture environment. We need to make sure that they have access to our applications, our shared services applications. So ultimately, over the course of that time period, you result in this hybrid cloud architecture that you didn't think about 7 years ago, in terms of thinking through the right way, in terms of what are the business drivers, what are the technical requirements, how do I want to think about this through the lens of simplified operations, advanced networking, robust, resilient architecture, as well as the right security controls and governance. And so that next gen hybrid cloud architecture, that Cloud 2.0 initiative that we're starting to see, is organizations in the healthcare industry doing just that. Like, let's take a step back. If we were to start over, essentially, knowing what we know today and knowing what our architecture is today, again, thinking through the lens of what are the right business requirements, what are the right technical requirements, how would I go about building out this hybrid cloud architecture the right way to support the right operational efficiency and cost controls, in terms of just making sure that cost is predictable and not continuously unpredictable and rising. And then how do I get the right network architecture, and how do I get the right security architecture? So that would be, kind of how I think about that, Sam, would be use this HIPAA, requirement mandate as essentially a call to action in the healthcare industry to say, first of all, how would I do this in my current architecture? It'd be very, very complicated. It'd be very, very challenging. And you may just be, adding additional complexity to what you're already doing. So the question that I want everyone to ask themselves, that I talk with a lot of healthcare organizations about, is, can you keep going down the road you're going, or is now a good time to pause, take a step back, think about what is the right hybrid cloud architecture, taking into account everything that's going on in AI and everything going on in cyber and everything going on relative to these proposed HIPAA mandates, and think about what is the right hybrid cloud architecture, and how can we build a sequence and a plan and a project and an initiative to, over the course of the next set time period, get into the architecture that's the right architecture for the organization.
Got it. That's super helpful, Tom. Thanks.
Absolutely. Good question. So what I wanted to do is introduce Cloud Native Security Fabric, and this is a new market category that Aviatrix is spearheading, and we believe it's very important in the regulated industries like healthcare, but also in financial services, and we'll start to see other industries really lean in towards it as well. But one of the things that we thought about when we created this new market category is specifically for regulated industries like healthcare and financial services is that cloud 2.0 or that next gen hybrid cloud architecture, however you want to think about it. Well, what is a cloud native security fabric? So starting from the top, it's making sure that it's a fabric that works across all of the cloud service providers, AWS, Azure, Google, Oracle, Alibaba, etc. It gives you cloud networking, which is advanced enterprise grade networking that leverages cloud provider APIs and native services where it makes the most sense, and orchestrates those services to make it very easy to build out the architecture, and then embedding security directly into the fabric. And we call that the distributed cloud firewall, but it's part of that cloud security component, introducing that real-time in policy enforcement, but in a distributed way. And I'll get into that a little bit more here in the future. It's got to be pervasive, right? It's, this fabric isn't going to do everything that you need from a security perspective or network perspective or operations perspective. It's got to be integrated into the ecosystem with Wiz and Splunk and Megaport and Equinix, and it's got to have a nice clean integration into the ecosystem. It's got to be dev friendly, right? It's got to support Terraform. It's got to be API first in engineering development. It's got to be automated, right? And what we're seeing, relative to combining these two sections or functions would be SecDevOps, right? Being able to integrate security into the landing zone creation such that when your applications are spun up, they're already defined with the right policy in terms of what they need access to. So you're not having to go, find your security team and punch holes in a firewall, as an example, that causes delays in terms of building out those application environments. It has to be performant, right? It's the cloud. It needs to be auto scale. It needs to be able to scale up when the demand is there and down when it's not, right? To save costs on the environment. But it's also got to be high performance encryption, right? Back to the, kind of the HIPAA changes where a lot of these first party transit services are unencrypted, right? Your Amazon Transit Gateway, your Azure vWAN, your Google NCC, these are unencrypted services. And so there is a dependency that you're encrypting at the app layer. Well, we know how complex that is, and we know how application teams accidentally forget to encrypt certain segments of their application. We also know that there's legacy applications that don't support encryption. We also know there's some homegrown applications that exist in healthcare as well, which creates challenges where you have flows going across your hybrid cloud architecture that are unencrypted. And then lastly, low latency, right? You need to make sure that packets are getting from point A to point B as quickly as possible. And then lastly, accelerated time to value. It's got to be very quick to implement. It's got to be a software-defined overlay. It's got to be, the reason it has to be a software-defined overlay is you have to create an abstraction layer between the variances of AWS and the variances of Azure, the variances of Google. You create that layer, that abstraction layer that sits on top of those cloud providers, and you're able to get that common set of operations, network security, and tooling. And then that overlay or that platform basically hides the variances below it. And then obviously simplified workflows to make things very easy to manage and maintain. So this is what a cloud native security fabric is. And again, this is something that Aviatrix is spearheading, and it's largely based on all of the conversations that we've been having for the last 10 years, 11 years of existence, as well as working very closely with our customers and figuring out exactly what they need out of their hybrid cloud architecture. So here's what an Aviatrix cloud native security fabric looks like. I want to get into the tech just a little bit here so that when I get into the case studies, it makes sense in terms of how the Aviatrix platform is helping these Blue Cross Blue Shield entities and their specific use cases and the specific solution. So what you're seeing here is an Aviatrix high-level diagram. Up on the top there, you see the control plane. This is a controller and what we call Copilot that ultimately is available in the cloud provider marketplace. You can go to the marketplace, you can search Aviatrix, you can spin up the controller, and then onboard your cloud provider accounts. You just need a single controller that's enabled with high availability, and then you can manage and build out a hybrid cloud architecture. So now you have one place as an automation point, and as well as tools and ability to configure and troubleshoot your hybrid cloud architecture. As you can see, we do support Terraform. So everything, we are a Terraform partner and provider. So you can build everything that I'm talking through right here with infrastructure as code. If you look down in kind of I'll say purple, purplish blue squares here, you see a hub architecture. This hub architecture has red circles in it. These are called gateways. These are Aviatrix gateways that are running on EC2 instances in AWS or virtual machines in Azure, et cetera. They are fully deployed and managed via the control plane, okay? And you build out this transit architecture, again, that is fully meshed and that gives you that repeatable, consistent architecture across these three different clouds. Then you build out the spoke layer, which again, these are gateways. They just take on a different persona called spoke gateways. And they build out this hub and spoke design, again, that's repeatable in every one of the public clouds. And by doing it this way, you now have a network that's common. You have a set of capabilities in terms of networking and operations and security that's consistent across the different public cloud providers. And then what we can do is now we get to see every flow, not we, you, as through the Aviatrix Copilot, you get to see all of the flows that are traversing your Aviatrix fabric, right? You get to understand who's talking to who and should they be talking. And, you know, you get alerted and notified should an IP address show up inside of your cloud that maybe is a malicious one. We integrate with Proofpoint, so back into that ecosystem to be able to detect malicious flows in your architecture. And we also added something called distributed cloud firewall into this fabric, so that all of those spoke gateways are also firewalled. So again, you can build a policy that says production can't talk to dev. You build it one time, you could do it via Terraform, and we could use tags on the instances, we can use CIDRs, we can use VPC or VNet IDs, we can use a lot of different constructs to define this production versus dev grouping. But then you define it, and no matter where they are in your hybrid cloud architecture, the policy will get applied at the spoke level, and then it'll get enforced at the spoke level. So it's a very different model than the lift and shift that the next-gen firewall vendors are doing, which is build a central firewall service and, you know, service insert everything, all of your flows to it, which has some drawbacks and challenges, and I can get into those. But distributed cloud firewall gets embedded into the Aviatrix fabric. Then you also have secure VPNs. So we call this site to cloud. And this is connecting into the Aviatrix fabric, maybe over to a hospital or a research partner or a contractor to give you that encrypted VPN connection to them. And then you can apply that distributed cloud firewall policy to those VPN connections. So you make it very easy to control what access those hospitals have access to. And everything is encrypted in transit. And then lastly, what you'll look at the bottom is you see Aviatrix gateways in the data centers, right? This is a very common and popular use case in healthcare because a lot of the EHR systems are still self-hosted in the data center. But all the clinical apps and telehealth apps and all the different apps that are necessary for the patient support are running maybe in the cloud, right? So you have a lot of PHI data that's going in and out of the public cloud and down to your data center. So one of the things we do is we offer a patented high-performance encryption technology that allows us to encrypt at near-line rate. That's why you're seeing that 100 gig type encrypted performance on that connection, because you may have 100 gig worth of direct connects or express routes where you're paying for these private circuits, again, that are not encrypted by default. And so you're dependent on other means to encrypt that data. Well, Aviatrix can give you the ability to encrypt those private circuits into your public cloud and into your data center for those flows at near line rate. So that is a very common use case as well. Sam, any questions before I move on into the use cases? Oh, you're muted.
Go ahead, Tom.
Okay. All right, so what I want to do is start with the first use case. So the first use case, if you look over on the left-hand side, it's a large state-based plan. And they, in particular, from a technical perspective, had 2 AWS regions, 2 Azure regions. And their problem was really that data transfer cost variance. It was rising. It was unpredictable. It was really hard to get control over those data transfer costs. And then the other kind of problem they were having is they were struggling with really keeping up with the regulatory and compliance needs of that multi-cloud architecture. And so what Aviatrix talked to this particular Blue Cross Blue Shield entity about was the fact that we don't charge based on data volume. And I think that's a really big point I would ask that you kind of underline or highlight. When you're sending a lot of large amounts of data across an Amazon Transit gateway, as an example, you're paying for the connection to the VPC, and you're also paying based on the data volume that is going through that service. And with Aviatrix, we replaced that transit gateway with an Aviatrix transit architecture, which is what you see here. And now you can send as much data as you want through that fabric without paying for the data volume aspects of that architecture. At least to Aviatrix, there's still some data transfer costs that you have to pay because the transfer is happening in the cloud. But we're able to get rid of a big part of that data transfer cost. And then the other thing with the regulatory and compliance needs, we were able to show them how all of this Aviatrix architecture across these 2 regions of AWS, 2 regions of Azure are fully encrypted. You get the right level of visibility into PHI flows and things that making sure you understand who's talking to who. Again, we're also alerting if there's any malicious flows happening inside that architecture, which help them get closer to meeting the regulatory and compliance needs. This resulted in 52% reduction in multi-cloud networking spend by eliminating many of those data transfer fees, as well as uptime relative to one of their core applications around enterprise data marketplace. So the Aviatrix architecture is built in a very highly available, dynamic way that allows the fabric to be able to stay up regardless if the cloud providers services may go down in a certain area, as an example. So maintaining resiliency, getting closer to compliance, and saving some costs relative to their data transfer spend. All right, the next one is a super regional state-based plan. And this particular Blue Cross Blue Shield entity has multi-region of AWS, multi-region of Azure, and multi-region of Google. So this one's in 3, and they also have data centers. And the problem they were having was onboarding new partners was slow, it was manual, it was complex, and a very expensive process. And their team had skills gaps and dealing with these different cloud provider variances, and how you do it in AWS is very different than how you do it in Google. And they had a very ineffective segmentation strategy across those 3 different clouds. And so they turned to Aviatrix Cloud Native Security Fabric and give them the ability, again, to build out that repeatable architecture across AWS, Azure, and Google, and then leverage Aviatrix for network segmentation to basically can say, this group of accounts or VPCs or VNets can't talk to these VPCs or VNets through network segmentation. And then what we did relative to, again, integrating into the ecosystem and making it very easy, we partnered with Palo Alto to be able to insert those Palo Alto firewalls into the Cloud Native Security Fabric. So rather than using Aviatrix Distributed Cloud Firewall, we also can integrate with next-gen firewall vendors to do that centralized design and make it very easy to do that service insertion. And also, again, it's very repeatable across the different public clouds. And then, of course, we gave them the ability to centralize their management with controller and Copilot and automation. What they were able to do, this particular Blue Cross Blue Shield entity also had their crown jewel application built in Google, and they actually moved their electronic health record to Google. And part of that project was that they needed 20 gigs of private API access into the Google API, and we were able to show them how we were able to do that, and we were able to help them achieve that. This allowed them to onboard major partners in weeks, not months as well. So we were able to expedite their ability to onboard new partners. This is what the architecture looks like. So again, the control plane sits up in their public cloud environment, and then build out that repeatable hub and spoke architecture across the 3 different clouds, multiple regions. You'll notice firewalls are sitting inside of the hub VPC. That's what we call FireNet. This is, again, Aviatrix takes care of all of the deployment of the firewalls, the service insertion, the route stitching inside of the cloud provider in order to make this happen. And then you'll also notice Epic sitting inside of the Google Spoke VPC. This is their EHR system that was running, that's running on top of Aviatrix, on top of Google. And then the last case study I want to walk through is an independent state-based healthcare on the West Coast. And their particular environment was 2 AWS regions. And then phase 2 will be Google. So they know they're going multi-cloud. And their particular challenge was all of their VPN connections, their partner VPN connections, were terminating in a physical data center on physical hardware. Well, that physical hardware was coming up for end of life, and they needed to determine, are we going to refresh this physical hardware? Or since we've moved all of our applications up into Azure, does it make sense to swing those VPN connections up to Azure and then let that hardware just go? And that's what they decided. So what they did was they moved those VPN connections up into Azure, and they terminated those VPN connections on an Aviatrix cloud native security fabric architecture. But they also still needed encrypted, high performing connectivity back to their legacy applications that still sat inside of their data center. So as you can see on this drawing here, they have an Aviatrix hub and spoke architecture in Azure with where those IPsec VPN connections terminate to where their Azure applications currently reside. So again, low latency, encrypted, got the right firewalling control in terms of what those partners have access to. And then they have this high performing link between the hub VPC and down into their data center where their legacy DC apps are, where again, they need that high performance encryption. And then in the future, when they add Google to the architecture, they can now rinse and repeat that architecture into Google and connect Google down into their Aviatrix gateways running in the data center and get that, again, common network, common operations, common security architecture. Those are the 3 case studies. Sam, I don't know if you have is there any questions in the chat or anything else? If not, I'll turn it back over to you.
Yeah, no, we have 2 questions that we wanted to ask. I see the first one being, does Aviatrix replace any native transit services?
We do. Yeah, we do. And again, going back to that first case study, they actually had the Amazon Transit Gateway. They actually had the Amazon NAT gateways that were performing the NAT function in their VPCs. We were able to replace both of those services. So the Aviatrix spoke gateways can perform NAT. So again, you don't need to pay not only for the hourly cost, but the data transfer cost associated with using the Amazon NAT gateway. You get to just use the Aviatrix spokes, just enable NAT, and we'll NAT that traffic and give you the visibility and the security before that traffic goes out to the internet. And then with the Amazon Transit Gateway, we can absolutely replace that with our transit as well. The thing I would probably highlight relative to that, Sam, would be in some cases it's not always replace the current service with Aviatrix. There may be a situation where a prospect or a customer just needs encryption from the cloud to the data center, right? And in that case, what we would do is we'd build out the hub VPC with Aviatrix, we deploy Aviatrix in the data center, but we'd keep your current transit gateway or VLAN in place, and then we would just peer with it. And now you get to kind of do it in a phased approach. So there may be a situation where we don't replace right away, we integrate into that service as a place to start your journey towards the right hybrid cloud architecture and improving your security posture. Hope that answers your question.
No, that does. That's super succinct. One last question that came up, Tom, is how does Aviatrix get around the standard 1.25 Gbps IPsec limitations in the cloud?
Yeah, that's a very common conversation. I think one of the challenges organizations have had relative to encrypting all your data in transit in the cloud is just that, right? That 1.25 gigabit limitation, and really what that's caused organizations to do is kind of have a decision to make. Do I get encryption? Because they can do it today without Aviatrix, they can do encryption in transit, but they're going to be limited to 1 gig, right, from a performance perspective. Or do I use the native first-party services like Transit Gateway, VLAN, et cetera? It's unencrypted, but you're getting 45 gigs, right? So you're getting a lot more performance out of your cloud architecture. And then I'll just encrypt at the app layer. With Aviatrix, we remove that decision, right? We give you the ability to do like 70, 80, 90 gigs of encrypted throughput inside of an AWS region. So actually twice the speed of Transit Gateway with a fully encrypted transit solution. And the way we get around that is actually a patent. We have a patent called high performance encryption. And to get into the weeds of it a little bit more, the reason why, the Cisco's, Junipers, Aristas, Palo Altos, they're limited to 1 gig in terms of when they're peering with first party constructs is because they only get to use one of their vCPUs to do the encryption and the de-encryption. With Aviatrix and our patent, we use every vCPU. So if you have an instance in AWS that has 16 vCPUs, we actually use all 16 of those vCPUs for packet encryption and de-encryption. That's what allows us to see those types of performance numbers.
Got it. No, that's super helpful, Tom. That's going to probably wrap it up for our questions that we have, and we're almost at time. Thank you, Tom, for everything and the succinct updates into the case studies. Yeah, thank you. For everyone that's attended, thank you for attending. We're going to have this recording as well sent to you. And for those that didn't make it, we'll be sending it to them as well. But yeah, this is going to wrap us up for a Blue Cross Blue Shield overview and case studies of how Aviatrix has helped. Any questions as well, that'll be, feel free to respond to the email being sent to you. And thank you again for joining.
Thank you, everyone. Have a good rest of your day, Sam. Bye, guys.
Thanks. You too, Tom.